So I'm going to create a triangle. So let's go ahead and do that. Here you go. There you go. The missing side of the triangle is 4. I mean, come on. It is giving the answer, and it is also giving you the solution. How exactly did it find it? Hey everyone, welcome to my channel. Today we are creating a math gesture program. So the idea is that you will be able to use your hands to create some drawing, and with that drawing we will send it to our AI model, and that AI model will tell you how to solve it, what exactly it is, and we can even add a lot more to it. We can ask questions about a drawing. We can make it a game that if you draw something, the AI has to guess it, and so on. So what we will do is we will split it down into different parts, and then we will start coding. So to do that, what I've done is I'm here in Canva, and what we will do is we will create an overview of what exactly are we building. So if we type out first that we are going to do a math gesture. So this is our project. We are going to split it down into different parts so that it's easier for us to know and it's easier for us to code. So the first part is detecting the hands. So what we'll do is we will type in here hand, and I think that's a good image. And that's our first part. We're going to write text, and here we are going to write detecting hand. So first of all, we are going to detect the hand, and then we are going to draw. So the second part will be to draw. I don't want to draw. I want an image of drawing. So instead, what we can do is we can write here drawing. There you go. Okay, let's use that. Then we have sending to the AI model. So we need to get the image, whatever we drew, we need to get it with a black background or white background, and then we need to send the data to our AI model. So we will write here AI model, and there you go, we have our image. So whatever the image that we collect, we are going to go ahead and send it, and along with that we are also going to send some data, some text, so that will be convenient for us so that we can give a little bit of background of what exactly do we need from the image. And then the last part is, once we are able to do that, we are going to create an app out of it. So we will write here app. So it won't be a mobile app, but okay, we have this, so why not? So we will create an app so that it is easy for us to request, draw, and do all of that. So that is basically our project broken down into 4 parts. In the first part, we are going to use CB zone. What exactly are we using it for? We are using it so that it's easy for us to detect the hand gesture, the fingers, and the number of fingers that are up, and all sort of that stuff. So that makes it easier. And then for the drawing part, we are going to use some basic logic. We don't need anything extra. Then to send the data to AI, we need to send it to a specific AI. Now ChatGPT, it works well. The OpenAI API is good, but the problem is that it is paid. So I don't want to do anything that not everyone is able to do. So we will use the free version, and that is Google Gemini. So we will be using Gemini to send the data and get the response. And then we need to create an app. So to create the app, we are going to use Streamlit. So we can simply open it up in our browser. We will have a graphical interface. We can interact with it. We can add and remove some images, and we can do a lot more with our app. So that's the basic idea of our project. We have broken it down, and I can see that you cannot see it from here. So let me move it up here. There you go. So that's the basic idea of this project. We are going to go ahead and step by step complete it. First thing we will do, we'll do the installations, and then we will start coding this. So I will keep this on just in case for the reference. Let's change the color a bit. It seems a little bit dull. So that's the idea. Here you can see now it looks a little bit better. Okay, so we can actually add the numbering. I like to do that as well. So there we have it. Our complete project is here now. And what we will do is we will start working on each of these steps. So the first thing we will do is we are going to go ahead and open up our PyCharm project. And this is the PyCharm IDE. You can install it for free online. And a few emails I get saying that they are not able to purchase PyCharm, but you don't have to, because there is a community version and it's completely free. So you can just download and install. So here what we will do is we will go to our main project and right click and create a new Python file. And we will name it main.py. So that's how we have created this main.py. And then we do have to install. Now the installation can be done from settings, and then you can go to project and then interpreter, and then here add, you can add. For example, we can write CVZone and we can hit install. Now this is one way of installing. If you don't prefer this way, you can use the generic way, I would say, which is applicable everywhere. You can simply click on the command prompt. Make sure you are in virtual environment. Here you are in the global environment. So don't install in the global, install in the virtual. So here in the command prompt, you are going to write, so here you can see it's in virtual environment now. And here you can write pip install. And for example, we do need to install MediaPipe provided by Google, which is actually the main idea of hand tracking. So that's how we do hand tracking. CVZone is just a wrapper to make it easier to run. So right now it's installing, and I hope the other one is installed as well, CVZone. So let's wait for it to install. So now that the installation is done, we are going to go ahead and import CVZone and import CV2. So these will be the two libraries we'll use at first. So what exactly are we doing? We are doing the first part, which is detecting the hand. So we are basically detecting the hand. That is what we are going to do here. So let me open up the project. So how exactly can we detect? So we can say from CVZone dot hand tracking module import hand detector. So that is what we are going to add. And if we click on the hand detector, how can you click? You can press on the control and you can click, and that will take you to the actual class. Now once you are at the class, you can go down, and right at the bottom you are going to see a sample code. Now if you don't want to do all of that, you can always go to the CVZone documentation as well, which is on GitHub. So if we go to CVZone GitHub, there you go. So this is the CVZone GitHub. And if we go down, you will see we have the hand tracking module. If we click on that, this is the sample code. So this and this, they are pretty much the same. So whatever you have in main, it's pretty much the same. So we will copy all of this and we are going to go ahead and paste it in our main file. Now we will select all of that and we will go one step back, because in Python you do have to keep note of the indentation. So if the indentation is wrong, the code will not work, which means if it's a little bit forward, it will not work. You have to go in the proper steps. So here, first of all, we will change the hands to 1. And then, by the way, how do you do that? You can press tab to go forward, and you can press shift and tab to go backwards. And if you select all of that, you can again do that, go forward, and shift and tab to go backwards. So that's the basic idea. We will keep everything same here except for the maximum hands. We just want one hand. And then here it shows the example of 2 hands. So we don't want that. We can remove all of the things for the second hand. And yeah, that's pretty much it. So if we change our ID number here, so if you are using a laptop or if you have just one camera installed on your PC, then you probably can use 0 and it should work fine. But because I have multiple cameras, I'm going to put 1, and that will probably work for me. And there we have it. You can see that we have our image. Now the mic might be a little bit of a problem. So now you can see if I move my hand, it is telling me that this is the right hand. And if I bring in the left one, this is my left hand. And I can also see the distance between the fingers. Now you could use this to draw, like if you click and then you can draw, you can do that. Or you can say that if I have 1 finger, then draw. If I have 2 fingers, then don't draw. And if I have this, do something. And it's up to you what you want to keep the gestures as. So what we can also do is, this is by default, it is 640 by 480. So what we can do is we can change it to 1280 by cap.set. This is prop ID 4 is the height and prop ID 3 is the width. So that's why we are writing here. So if we run that again, so this time around we should have a bigger image. Now, given that your camera is able to do this, so you can do that. So here you can see I can move around, and that's pretty much it. And at the bottom, it is telling you how many fingers are up. So here you can see it's 5. If I put 1, then it says 1. If I don't put anything, it says 0. Now it's 2, 3, 4, and 5. And not only that, it will also tell you which fingers are up. Not just 2 fingers are up. It will tell you index and middle fingers, they are up. So that's also convenient. Now for the distance part, we are not going to use it, so I'm going to remove that. And how many fingers are up is basically in this. So if I print this, print, and if I write here fingers, and if we run that again, then it will tell me how many fingers are up. It will give us a list and it will tell you how many of those are up. So here you can see it's 0, 0, 0, 0, and right now it's 1, 1, 1. So if I move here, you can see only 1 is up, then 2, then 3, then 4, and 5. And from this, we can get the information that which one is up. So here you can see the last 2 are up, and here you can see the index 1 is up, and so on. So that is quite useful for our purpose. Okay, so this is the first part, which we have done very easily. There were no hiccups, no problems, no errors. And now the second thing is the drawing part. So now we need to apply some basic logic to draw. So how exactly can we draw? We can basically create a canvas and we can draw on top of that, and then we can attach that canvas back to the main image. So that way it will be an overlay on top of that image, and it will not remove anything that we have drawn, because this image that we are getting from our webcam, it basically updates every second 30 times. So it's 30 frames per second, so it will update 30 times per second. So we cannot draw on that. Otherwise, whatever we draw on the first frame will not appear on the second frame. Now, there are workarounds to that as well, but we're not going to go into that much detail, because we do need a separate image to actually draw and send it to our AI model. So what we will do is we will try to do everything in functions. In fact, we could put this in a function as well. Instead, let's do that first. Here we are going to write def, let's say get and info. So this will give us the and info, and what we need to send in is only the image. So here we will send in the image, and we will take all of this, whatever is related to the hand, and we will put it in our function. So why are we doing this? Because sometimes you want to use this in different projects, and in that case it becomes very easy to just grab a function which has an input and a specific output, and it becomes very easy to replicate projects. So we don't need any of these three, we just need the list. The LM list, instead of 1, we can remove the 1. So we are going to use the LM list, which is basically all the landmarks, all the points of the tips of the fingers. So we do need to know where is that. So we are going to use that. And then we also have the fingers, the list of fingers, how many are up. So that we need as well. Okay, so what exactly are we going to return from this? So in the case that the hand is detected, we are going to return the fingers and the LM list. So these are the two things that we are finding out. So that is what we are going to return. If that is not the case, we can simply return nothing. So that's the idea. Instead of returning twice, we can simply just return once. So none. So if there's nothing in there, it will not return anything. It will return a none. And if there is something, it will return the fingers and the LM list. So what we can do is we can write here get hand info, and we can send in the image, and we can also write here that we are getting the info. So next on, whatever happens, we can say if info is available, then do something. If info is none or it's empty, then it will not do anything. So we don't have to worry about that. So we can parse it and we can get this info. So this is basically unzipping of your list, and we are getting the values and then we are printing it. So let's run it just for the sake of it, that everything is working, and then we can move on to the next step. So there we have it. It is working, and as you can see, I can move my hand around, and that's pretty much it. So if there's nothing there, it is not showing us. So it is detecting sometimes wrong, and maybe we can increase the detection to 0.7 so that it doesn't do that. So now that we have this ready, now we need to go to the second step. So now the second step is drawing. So we can simply write here draw. So what exactly do we need to draw? So we need to draw on a canvas whatever we are getting when we have our finger up. So first of all, we need the information of the fingers. So either we can get all of the info, or we can get just the finger information, the finger list. So in this case, we're getting all of the info. So maybe we'll use it later as well. And for now, let's just do that. And we just need the info. And once we have the info, we are going to parse it. So here you can see we have fingers and lm list equals, let's say, info. And once we have that, now we are going to check how many fingers are up. So we want to draw when only the index finger is up. So it will be 0, 1, 0, 0, 0. So it will be like this. So when this is the case, then we want to draw. So we will write if fingers equals 1. So it will be thumb will be 0. Then this will be 1. This will be 1. So 0, 1, 0, 0, 0. So this means only the index finger is up. So now what we can do is we can draw. So how exactly can we draw? So we can simply draw a line between the previous point and the next point. So 2 points we need to draw the line between. So we can write here cb2 dot line, and here we can draw the line between 2 points, the previous one and the new one. And where do we want to draw it? We want to draw it on our image. For now, later on we will create a canvas and draw on that. But for now we will just draw it on our main image, which we already have. So now we need to give in the positions. So here what we will do is we need the current position. Current position equals lm list at point number 8. Now, why exactly are we getting point number 8? Let me show you that. So here you can see our index tip is point number 8 and middle finger tip is point number 12. So what we need is point number 8. So that's the basic idea. So here you can see, you can get different gestures using this. So that's why we need point number 8, and we get X, Y, and Z. So we don't need X, Y, and Z. We just need X and Y. That's why we have written 0 to 2. So it will give us 0 and 1. It will skip 2. 2 is not included. It's excluded. So current position will be X and Y of point number 8. So here we can write current position. And then we also need to give in the previous position. So the previous position, what is that? So if previous position is none, then we do need to do something at the very start. So we will say that if previous position is none, then we are going to write previous position is the current position. So it will draw a dot. If it's the first time it's drawing, so then it will draw a dot. But it's giving us an error because we didn't ask for the previous position. So here we are getting our previous position, and we will declare it globally, so that here we can write here previous position, prev position equals none. So that is the idea. And then once we call the function, if it's drawing for the first time, it will be none. If it's drawing again, then it should be fine. Okay, that being said, now what we will do is whenever we have drawn, we are going to return our current position, because next time that will be our previous position. So here we are going to say return current position. And every time when we start, we are going to put the current position to 0, because if it did not detect anything, then it has to return something, and it will return it as none. So when it returns this as none, the previous position will become none, and then it will start from the new position. Otherwise, whenever you draw something and then you remove your finger and you go somewhere else and draw, it will draw a line between that previous position and the new position. So every time we need to reset it when the finger is lost. And that will be done by doing this. Current position is none, and it will become none when there is no detection. Otherwise, it will give it a value. So that's the basic idea. So I believe that's this is the color. We have given it a purple color. So 2550255 means purple. It is BGR. And then the thickness is 10. So that's pretty much the idea. And then what we can do is we can simply call this function. After we detect something, we are going to call it. And what we can do is we are going to send in our info and the previous position. And then what we are getting back is our previous position. That's the idea. So if we run this now, hopefully it is going to draw something. So if I move this finger now, you can see it is drawing, but it's creating a line between the previous frame and the current frame, and it's not doing anything else. So that is what is supposed to happen, because we did not define any new canvas, and as I mentioned, we need to overlay it on top of that. So what we will do is we will create a new canvas, and on top of that we are going to draw everything, and then we will merge these two together. So here we are going to write canvas equals none. So initially the canvas will be none, and when it starts, then we are going to draw the canvas based on our image. The reason we are not giving it in the beginning is because we don't know the size of the image. Now in this case we do know it is 1280 by 720, but in case we didn't know, then it will take it from that image and it will try to copy that. So that will be useful for us. So here we can say if canvas is none, then for the very first time we are going to create a black canvas. So how can we do that? We can use numpy, and here we are going to write canvas equals numpy dot zeros like image. So whatever size of the image is, copy that and put it blank, make it a 0, make it black. So that's how we are going to get this canvas. And once we get that, we are going to send it over here so we can draw on it. So here we will send it, here we will receive it, and here we are going to draw on it. So here instead of image, we are going to draw on the canvas. So what this will do is it will draw on the canvas and it will remain there. So what we can do is we can show the canvas as well. So here we can write if canvas is none, do this. We are going to write here canvas, and here we will write canvas. So now it will give us two images. If we draw now, you can see it is moving. Now we have a few issues here. The first one is that it is flipped. So if I go right, it is going left, and it is not very convenient. So we need to flip the image. So here, once we get it, we can simply write image equals cv2 flip image, and the flip code is 1, which means we are flipping it horizontally. So now that should be fixed. Now the second thing is we need to overlay this canvas on our main image so that we can basically see what exactly is going on. So here we can return this canvas, and now we can merge these two canvases together. So we can say here image underscore combined equals, we are going to use cv2 dot add weighted, and then we are going to add our image and canvas. Both of them we will give it a value. For the image we will give, let's say 0.85, and the remaining 0.15 will be for the drawing. So the drawing will be lighter than the image, otherwise it will give it a very black effect and it might not look that good. So what we can do is we can write here another image, should be combined, and we can just copy this part and we can paste it here. Okay, so now but the problem will be it will give us an error, because if it doesn't detect this, then it will say it didn't find image combined. So what we can do is we can simply write here image combined equals none. So let's run that and see if it will work. So there's an error because none cannot be displayed. So what we will do is we will make the image combined. So if the canvas is none, for the very first frame only, we will say image combined equals image copy, the main image copy, so that it doesn't give us an error. Otherwise it will give us an error again. So here you can see it's not showing us anything. It's stuck because it just copied the first frame and now it's waiting for the hand. So what we can do is we can say that if it is detected, that's all good, but if it's not, or what we can do is we can always show image combined. Doesn't matter what the case is, we always have to show image combined so that it keeps updating it. Otherwise, if it gets stuck, then you start drawing, it starts again. It looks a little bit bad. So there we have our image combined. Now it's real time. And if we draw, you can see it is drawing as well. But the drawing is very light, so we can increase it here. So let's say we will make it 0.3 and we will make it 0.7. So it has to add up to 1. So that's the idea. So as you can see, now the image is getting a little bit darker so that we can see more. So there you go. I think this is quite smooth and it works well. So here you can see the drawing is very smooth. If I put my second finger up, it will stop drawing. If I put it down, it will start drawing. So there you go. So I think that is a good way to start and looks good. So now the good thing is we already have the image that we need to send to our API. So if we look at our canvas, that is basically what we need to send. So if I draw, you can see this is the image that we need to send. So we already have it. Now all we have to do is we have to send it. So let's go back to our whiteboard, and there we are going to have a look at how much we have done. So we have detected the hand, we have done the drawing, so that's pretty good so far. If you have followed along and if it's working, congratulations. Now what we need to do is we need to integrate the AI part. We will take our drawing and we are going to send it to our AI model, and in this case it will be Gemini. So how exactly can we get started with Gemini? So if you go to Google and you Google AI for developers, or you can write Gemini API quick start, it will take you to this page, or I will add it to the description as well so it's easy for you to find it. So Gemini API quick start, it is telling us about Python. You can check for Node.js, Go, Flutter, Android, Swift, web, whatever you want. So here what we can do is we can look at how exactly can we run this, and as you can see it's so simple. It's one line here and a few lines here, and that's pretty much it. So that's what we need to integrate, and that's why it's so easy to get it up and running. And the good thing is here it's only showing us for text. We also have the option of sending the text and an image as well. So we will look into that. And here they are using Gemini Flash, which is a newer model which gives good responses at a faster rate. So we will be using that as well. Okay, now before we do that, we do need to get an API key to add it here. Now, you will not be charged for it, but if you upgrade, of course, you will have to pay for that. So here you can see we have our API keys. You can create an API key, and whatever that says, it's okay. Select a project, that you want to do. And here we can write, for example, here we can write that this is math gesture. So this is our new project. I already have this API key, and here you can see the plan. It's free of charge, and you can set up the billing as well. Now, how much do you get, and how many queries can you send? So let's go ahead and check Google API Gemini pricing. So hopefully that will give us the idea of getting started. There you go. So this is basically free of charge. You can request 15 times in 1 minute. I mean, that's a lot. 1 million tokens per minute. Again, that's a lot. And requests per day is 1500. And I mean, that's a lot as well. So especially if you're experimenting, I mean, that's more than enough. And which model is it using? Gemini Flash. So it is telling us about Gemini Flash. If you go to Pro, you will get less of the tokens and less requests per minute. So yeah, if you want to use that, you can use that as well. Let's try 1.0 Pro. You will get more because it's a older version. So what we will do, we will be using the Flash model today. And if you want to use any other ones, you can use that as well. If you want to use ChatGPT, you can use that as well. Now I have my API key here. If you click on that, you can copy it and you can get started. Now it's free of charge, so don't copy my API key, please. Now I'm not hiding it or anything, but please don't copy my API key. So you can generate your own and get started. Okay. So that being said, I have copied that. And before we do that, we also need to install this. So we will just copy this. We need to install Google Generative AI. So we will go to our terminal, and here you can see we are in our virtual environment, and we can simply paste and we can hit enter. And then this will give us the installation. So while it is installing, we can go up, and as you can see, it is already structured quite well. So this was our part 1, that is good. This was our part 2, again good. And now what we need to do, we need to do part 3. So we will make another function. So that's how simple things are. Okay, it already knows what we are thinking, and that's why it is giving us the suggestion. So, okay, we will take the suggestion and we will write it. Send to AI, and we need to send our canvas, and we need to send it when we have a particular number of fingers up. So for example, when we have 3 fingers up like this, like this, or let's say we have like this, then it's going to send it. So this is very unique, so it will not happen by mistake. So when we do this, it is going to send. So for that, we are going to write 1 1 1 1, and that will be like this. So that's the main idea. And here we have that if fingers are like this, then we are going to send it to our AI model. Now, how do we send it is a different story. So we are going to look into that now. So if we go to our API documentation, then here it says you have to import. Let's go ahead and import. And then it says you need to configure the API key. So instead of doing it through environment variables, we are going to do it the lazy way. I will show you the lazy way, which is simply writing it like this, and then you copy your API key and you just paste it here. I know that's not a good way to do it, but we are just testing. So give me a break. So we have configured it. It's all ready to go. And then if we go back to our API documentation, how do we generate? We simply write it like this, that we create the model like this. We can simply write it here instead, because we're simply setting it up. Once we have it, then we can simply send in the model, and using that model, we are going to generate something. So we will generate a response. So we will copy it from here, generate text. We will copy it from here and we will paste it here. So it will not just keep generating, it will only generate when we do this, right? So that's the idea. So we will write here over here that when we have the finger up, then we are going to send to AI. We will send in our model. We will send in the canvas and the fingers. Now we will use those later on, but we do need to send them, right? So here we are going to send it and then we are going to run it. So if we put up all our fingers here, then it should be sending and it will be giving us a story about a magic backpack. So the moment of truth, if we do this, you can see it gets stuck, which means it is generating something. So hopefully there will be a story here. Now it is a story, that's why it will take a while. But if it was something smaller, it will be quick. So for example, we can say, which is the largest ocean? So hopefully this will be very fast because it's just a single word answer. So here we have it. We can draw. Once we draw, we can send it and it will get stuck. And there you go. The largest ocean is the Pacific Ocean. So we are getting our answer and exactly when we want it. So that's very good. And if you have followed along so far and it works, then good job. Hats off to you. And then now we are going to go ahead and actually send the image. Now, how do you send the image? Now, to send it, it's not very difficult, but we do need to send it in the format of PIL. So we need to import PIL from PIL import image. So we need to import image because we need to convert it before we send it. So that's why we need this. So what we will do is once we get that, we are going to convert our image to PIL format. So we will write here that our PIL image is image.fromArray. We are converting our canvas because it is a NumPy array. It's a NumPy canvas. So we need to convert that into a PIL format. Now, once we have the PIL format, what we need to do next is we need to send it to our model. And in order to send it, all we have to do is we have to add a bracket and we need to send in both the information. So here we will write here response equals model.generate content, which is exactly the same. And instead of just sending this as the text, we will send the text and the image, and that's it. I mean, how easy it could be rather than this. So it is very easy. And then we will get the response from this text. So here we are saying solve this math problem, and then it should give us the image. Now, if we run this now, it should print us the answer. So here, let's say we are drawing now, and I will write here 5, and I will write plus, and I will write here 3. Right? So now we are ready to send. So I will put up my fingers and let's see what it says. So here it gives us the answer 8. So I mean, come on. Right away it works without any issues. So the image that we sent was this 5 plus 3, and this is our main image, and we overlaid on top of that, and everything is working, and that's pretty much good. Now, one thing we can add here is that once we are drawing, sometimes now I need to remove this and send something again, or I need to change something. So what I can do is I can add feature to remove all of the draws. So in the drawing here we have our fingers, and what we can do is that if all of the fingers are up, then we will reset our canvas. So if we can write here else if fingers are up, all of them. So if all the fingers are up, then it's going to reset. So how can we reset? We can simply do this again. There you go. So here we can run that again. And hopefully if we do this, it's going to reset. So we will start like this. So now if I bring in the image, you can see here it's drawing, and if I do this, it will reset. And then if I can draw again, and if I do this, it will reset. So that's pretty good. That's pretty neat. If you wanted to do that. Now, if you want to remove, you can also use, let's say, only the thumb. Then you can do this. It's up to you which gestures do you want to add. So sometimes people like to start like this, right? So it's a little bit difficult for them to do this. So for erasing, so here, for example, you do this, and oh, something is mistaken, I can do that and it will remove, and I can start again, and this is not an issue. I can remove like this, and there you go, and it works. Oh, I did a mistake, I don't want it. Refresh, and there you go. So that's the basic idea of how we can draw and continue. Now, the next step is very simple. We need to give it an outer structure. We need to give it a visual appearance so that it's easy for us to work around with it. And we will be using Streamlit to do that. So the first thing we will do now is we are going to go ahead and install Streamlit. So here we will write pip install Streamlit. And Streamlit is very easy to use. So all you have to do is you have to write here import Streamlit as st. So what we will do first is we are going to expand it to full width. And what I've done is I've also created an image which will allow it to be a little bit more pleasing. So I will import that here. There you go, mathgestures.png. So here we are going to add that so it looks a little bit appealing. Now, if I add it without doing anything, then it will be very limited. It will not be full width. I will show you what do I mean by that. So what we will do is we will simply add an image. So we will write here st.image, and inside that we will give in our mathgestures.png. So this will import the image and it will display it. But the issue will be that it will not span over the complete width. So let's wait for it to finish, and then we will try it out. Okay, so now that it's done, we can simply play. No, we cannot run now because we have added Streamlit. That is one thing that I don't like. We do have to write a script that we can double click, or we need to write it in the terminal. So here we will write in the terminal. So we are already here, and all we have to do is we have to write Streamlit run main.py. So we will run that and it will open it up in a browser, and there you go. So that is what I was mentioning, that if we don't extend the width, it will display it on a very limited area. So we don't want to do that. We want to extend it and we want to display it on the complete image or the complete browser. So how can we do that? We can write here, and that should be the first command for Streamlit, otherwise it will not work. Streamlit set page configuration, and we want to set it wide. So if we go ahead and refresh this, you will see now it expands. So that's good for us. Now, the second thing we want to do is we want to split it into two parts. So in the first part, we will have our image, the webcam running, and in the second part, we will have our answer, or we will have our reply. So that is what we are going to do. So in order to do that, we will split it up into columns. So how can we do that? We can simply write here st.columns, and we want to split it into two columns. Now, if you want to keep the same ratio, you can simply write here 2, and that will be 50-50 split. But if you want to change the split, for example, you want 70 and 30 or 66 and 33, whatever you want to call it, then what you can do is you can write it like this, 1-1, and here you can change the ratio. So 2:1. So 2 will be for the webcam and 1 will be for the answer, for example. So here we can do that, and we can write here column 1. What is that? Column 1 and column 2, and we will write it equals to this. So here we will write st columns. So that will generate 2 columns for us. And what we will do is now we will add on the placeholders. Otherwise, when we do it in the loop, it will be all messed up. So we need to add it in the very beginning so that it works. Right now, it is running in the background and it is solving these problems. So for that, we need to fix as well, because right now it is detecting and it is getting the images and it keeps running. So we need to fix that as well. I will show you how to do that. So what we will do is we will create a checkbox. So we will say in the first column with column 1, create a checkbox and call it run, and the value will be true. So this will be for the webcam. If we click on this, the webcam will stop. So that is the basic idea. And then we will create a window and we will call it frame window, and we will generate an empty image. So this is the placeholder on which we will add our image. And for the second column, we will write here with column 2, we are going to output our text. So we will write here that our answer is with the title, and our the actual answer will be with a subheader, right? So we are using st.subheader to write the answer and st.title to give the title of answer. Okay, so that being said, if we run this now, if we go back and if we refresh this, we should see some changes. So here we have the answer, here we have the run button, and here we should see the webcam. So how can we run the webcam? It's very easy. All we have to do is we have to send in the combined image. Now, how do you give in the combined image? It's very easy. We will take the name of this frame window dot image, and that's it. I mean, can it be simpler than that? So we will write here frame window dot image is basically your image combined. So now we are displaying our image, and what we can do is we can remove all of these because we are going to display it on the Streamlit. And if we refresh this, and there you go. So now we have our image and it's all good. And if we start drawing, you can see it draws. There you go. It draws. And if I want to remove, I can remove that. And if I want to send, what was it? Yeah, it was this. If I want to send, I can do this. So this seems a little bit better. So what we can do, so if we send, it actually sends the drawing, and here it says, please provide the math problem you would like to solve. Now we need this answer in our Streamlit. So what we can do is we already have this text area for it. So we will use that and we are going to write it down here. So, but the problem is that dot text, we can write it like that, and then that will be our text. But the problem is that we don't really have the text yet. We are just printing it out over here. So what we need to do is, instead of printing it out, we are going to return it. So the response.text will be returned, and we do need to return anything else. No, I think that should be fine. So we do need to return it over here, and we can remove the fingerprint as well. So here we can write our output underscore text equals this, and then we can simply paste it here. So now if we go back and if we refresh this, hopefully we are going to get something once we send it, and we get a beautiful error message. So output text is not defined because it is in this if statement. So we need to define it before it. Or instead of none, we can just write it like this. Why not? Let's go back. We are going to refresh this. So right now it's none. So if I do this and if I send it, the image shows number 2. So yeah, that's about it. So if we refresh this, let's try out. Before we do that, let me just check if there's anything left. I think we are pretty much done and everything seems to work. Now we can write here that if there is something in the text, then write it. Otherwise, don't just write none. It looks bad. So if output text, then do this. Otherwise, don't do it. So there we have it. Let's run it. And now let's go ahead and try it out. The moment of truth that we have all been waiting for. I'm going to write a math problem and see if it will work or not. So here I have my hand here. I'm going to create so I'm going to create a triangle. So let's go ahead and do that. Here you go. This is the triangle, right angle. There you go. We can also add an indication here. And then here I am going to write that this is 5 and this here is 6. There you go. And now we are going to send it. So the moment of truth, will it give the right answer or not? Let's find out. So it will get a little bit stuck. There you go. So it is getting the answer and there you go. The missing side of the triangle is 4. I mean, come on. It is giving the answer and it is also giving you the solution. How exactly did it find it? So, and this is not just for this, specifically triangles. You can ask it other questions as well. So for example, if we go back and we erase and we write 5 divided by 10. So if we send this now, we should get a 0.5. And there you go. The answer is 1/2. You can simplify this fraction by dividing both numbers by 5. And it is explaining as well. Now, one thing you can do later on is you can add to this that it narrates this as well. So that will be quite fun to watch how it actually understands and replicates all of that. Okay, so what else can we try? Let's say we write here that we need the square root of 20. And there we have it. So if we run that, you can see we have a square root of 20. And here you can see it's 4.47214. Now that works as well. So if you have any maths questions, you can basically ask it to do it for you. Now, one more thing you can do, which is quite interesting, is that you can change the text. Instead of saying solve this math problem, you can say guess the drawing. So if you write that, so here if we write guess the drawing, and if we go back and refresh this, now what I can do is I can draw anything and the AI will try to guess it. So let's go ahead and draw something. So my drawing is not that great, but I will try my best to draw something, especially in the air. It's a bit difficult. There you go. So let's see what it says. And it is a car. There you go. So hopefully you guessed it too, that it was a car. And then let's draw something else. So here we will draw this is the worst drawing ever, and hopefully it will understand it. So yeah, let's see. There you go. It says it is a tree. So that's pretty good. So we will go back and change it to solving math problems. So we will write here, solve this math problem. So that's the idea. So that is pretty much it for today. I hope you have learned something new. This was an interesting project because it's taking computer vision to another level, that it is able to intuitively give you answers using vision. So that's pretty interesting. And all of this is for free. That's really boggles me that all of this is available for free to use and the limits are not bad at all. So there's a lot of room for playing and experimenting before you can start doing some commercial projects. So that's basically the idea of this project. I hope you have learned something new. If you like the project, give it a thumbs up. If you loved it, share it with your friends, and I will see you in the next one.